probably be a week from today, the meeting, but again, I'll check for everybody, so that one's not firm yet. Questions for me?
No, what is that?
Yeah.
You finished on
Yeah. All right, other questions? Our equations of motion. So this is the set that's always true. These were our definitions. Then we have the sometimes true, and when they are, they're very handy. And Ms. Schmidt said she covered this for you guys. So I'll put that down for you guys. All right, so the always and the sometimes. What is that condition that we use the extra set of 3? What type of problem is it legitimate? Constant acceleration. All right. Now, what's going to be new on this exam is an integrative problem. So you'll have your sections just like you had on, say, the Newton problem. But at the end will be a problem where you'll take what you've learned in this unit and you'll combine it with the things from previous. Now, we only have had one previous unit. So if you were to guess, what is the one thing that connects kinematics with forces? Are you sure?
acceleration.
There you go. So anytime you're dealing with acceleration here, we know that we can relate it back to force how? There we go. So a typical problem might be one that you're used to, but then instead of stopping and saying, you know, what was that acceleration, we go to the next step and say, if you know the mass of the object, what was the force that was responsible for the motion that you just did? And of course, level 3 problems, they can be tricky in their own right. Should we practice something a little more difficult? Good idea? All right. We'll say that this is, well, we won't even say necessarily what type of problem it is. I'll just describe it and then you guys tell me. So we have a, we'll say we have a car. And it's going to start out at rest. So we say V naught equals 0. And we will speed up. And we will do it for 100 meters. And let's say it took us 5 seconds. First thing I want you to ask yourself is, what kind of problem is this? And then we'll talk about how we might go about solving it. Talk to each other for a minute.
Well, you figure out what the acceleration is by taking note of the fact that in 5 seconds it went from 0 miles to 100 miles. Assuming the acceleration is constant.
Eunice has a question.
The initial speed is 0.
Okay. She says it's a constant acceleration. Do we know that acceleration is non-zero? Yes, so it's not a constant velocity problem. So at this point we say either the acceleration is constant or we don't know how to solve it. We would probably need calculus. So let's say that it is constant acceleration. Now, can you solve this problem? Do you have enough information? Dwayne, you nodding? Yep, you do? All right. Would somebody like to suggest a method?
If you delta x equals v naught g plus half h squared.
Says go ahead and use this. All right. And so that will give you, we have a displacement, we have a starting velocity, we have the time. That will give you the acceleration. All right, let's do that. Let's figure out what that is. Now, I think I heard another method over here. You see if you get the same answer using your method, and if so, we'll share it with the class. It's a delight. That's why I had to sneak through there. All right, do you have the answer? What did you get? Okay, he got 8 meters per second squared. Everybody get that? Anybody get something else? Does your other method work? It's a dot. Okay, there is another method, but it wasn't quite. So what you might have been inclined to do would be to take your displacement and divide by your time to get 20, but that doesn't really fit anything that we defined. Is there another way to do this? What if I used this formula? Or maybe that's what you were doing, but not realizing what you were getting at the end was. Let's try that. If we take our 100 and we divide it by our 5, our average velocity is 20. Is that helpful? Okay. If we start at 0 and end at something and our average was 20, what did we end at? 40. So now if we took and divided 40 by 5. Okay, so another way to do it. In my head, this is the way I like to do them. I hate anything that involves squares. It makes me pull out my calculator usually. They are nice round numbers. Is that second method useful to anyone? You like to think like that, not like to think like that? You guys seem real blasé. Is this boring stuff? You know this already? It's not helpful? Tired? Would working more examples now be useful, or I can turn you loose and give you your test back. One person has a fix. If you have done everything that needs to be done, I have some review problems, kind of like what I was starting to do here, and I'll let you work through them on your own. Answers are at the bottom, so you can check. But actually, before I do that, let's take this one step further. Let's make it an integrated problem. If instead it said, what force is required for this action? Could we solve for that? We would need a mass. So I'll give you a car mass, say, 2,000 kilograms. Now, what was the force?
16,000.
He says just take the mass, multiply by the acceleration, 16,000 newtons. Now, if I'm persnickety, is that plus or minus? If we assumed our displacement to the right was plus, So delta x was plus 100, then of course our acceleration in that same direction was plus, and so our force would need to be in that same direction plus as well. If on the other hand we were to now brake instead of speeding up, let's bring the car to rest in let's say 20 meters. I want it back to 0 in 20 meters. Tell me what the acceleration is. Tell me what the force is.
How long would it take you to
I'm saying you go another 20. So that'd be a total. If you're at position 100, now if we're looking at like stripes on the pavement, now you're at position 120. So you've gone an extra 20 while you are braking. You might say, this is a little tougher, but you should expect something like this maybe for a level 3. So going from 0 to 40 wasn't so bad. But now we've turned it around and we're saying we're going 40 to 0. Now it looks What do you think, Josh?
Don't you
Did
need to
you
know
agree with the method we used for the first one?
either time? Don't you need to know
Well,
either
0 to
time?
40.
You can probably figure it out.
But if I turn it around and go 40 to 0, you go away. How is it from
Because you could say that you're slowing down at 5 meters per second or 7 meters per second. Change it.
So we'll have to make a start. Sorry? We're gonna, you can't say it's constant deceleration.
Oh, 20 meters.
We just don't have to.
Velocity equals distance over time. Equals distance. 20. U is U. 2 times. How would you do 20 over t squared to simplify it? What if we just...
How did you solve?
Delta V over T, or negative 40 over T, for each T. Times multiplied by T is 20 40 T plus 1 half 40, 1 half times not only gives you T equals 1, it means that now you realize 1, so 20, 40 plus 1 half. You need 8 times 1 squared gives you 30 equals
What did you guys get?
40.
And what are you going to show? What was your average? How far did you go?
So we're finding this zero. The initial is 40. The distance, which is 20.
How's the table doing?
So it's 40.
Diane, how are you?
This can't be right.
Did you get the first half? So we started with 0. We accelerated at an unknown amount for 5 seconds to go 100 meters. So we used that equation that I calculated. We plugged in the 100 on the left. The first term is 0. And the second term is 1/2 our unknown times 5 squared. So I'm going to multiply everything by 2. So now it's 200 equals 25 times 8. So 200 divided by 25 is 8. Okay. So now we got our acceleration. Now it sounds like we want to do the same type of problem, and I haven't given you the time. So there's 2 things. You can figure out the time, or you can go searching for a different equation. Both are legitimate. I like to think in terms of time. This table wanted the shortcut, just use the equation that didn't require time. Either way works. How's this table doing? Jack, how are you doing?
All right.
Yeah, do you have an answer?
Not yet.
Okay. What you working on?
I'm trying to figure out how.
Okay. So I started 40. I ended 0. What was my average?
20.
And how far did I go?
20 meters.
So I was going 20, on average, 20 meters per second. I went 20. How long should that take?
1 second.
There you go. Now you can use that same equation and use 1 second.
Does that mean I was right? No, that can't be right. That cannot be right. This is impossible.
That's not good.
It just cannot logically be -1 meter per second. I think it should logically be -2. Right?
So we're off at 40, right?
Yeah.
Okay, so at least 2 different ways to do this one. I don't know, I think there's a third one that you might have fun with. But anyway, how did you guys do it?
what we did at first was we found the initial velocity, which was at 100 meters.
Okay, so you will use this, correct? Okay, or I kind of did that one before. So, he says we are going to say what, D final, minus sign 0, or 5 seconds equal our, what, 8 meters per second squared? Multiply those. Multiply those, and you get 40 meters per second. So basically, the ending velocity here is the starting one here. So you can add another variable there if you like. 40 meters per second. And we're still going the same way, so we'll be explicit and put the plus sign. Now, what did you do?
From there, we used the formula for v final squared equals beta x squared plus 2a delta x.
So they like this one here because why?
We have 3 of the 4 variables.
And you don't need time, which you haven't been given. So, all right, let's do that. So our final, when we stop, we're going how fast? 0. And so here we put in 40, we're going to square it, plus 2a, and then we said we are going, our displacement here, our final minus initial, so I'll put in 20 meters there, and now it's much better. So, sorry?
When you solve, you get negative 40 meters per second.
So I'll put my 1600 here, and then I'll move it to the other side, so that's minus. And now I have my 40 times, let's see, that's 40 meters times my acceleration. So then it's minus 1600 divided by 40. So get back our 40, and our units went meters squared, seconds squared, divided by meters. So one of those cancels. And we're ending up with minus 40 meters per second squared. So we've got our acceleration units. We've got a big number. We're braking really hard to do that. What is the negative sign mean? Right. The direction now is opposite where we're going. If our velocity had been plus, then our acceleration now, so this was plus 40 meters per second velocity. Now we have negative 40 meters per second squared acceleration. So they're opposed to each other, and now we have acceleration. Again, we don't want to like say negative means deceleration, but if they're opposite, then you have deceleration. All right. Turn that into a force.
There's a mass of 2,000 kilograms, and we have the acceleration, so we can use F equals ma.
Okay, so that equals ma, and we're just going to multiply 40 by 2,000, so that's like 80,000. And do I keep that negative sign again? Sorry?
If you want to.
If I want, yes, I definitely do. Acceleration's that way, the force on the vehicle must be that way, must be opposite what it is. All right, so one way, pretty good way to do it. Another way to do it. Josh, did you guys make headway with the time? Okay. Did somebody stop along the way to get time? Tyrone, did you?
So you can, so because it's a constant gravity acceleration, your average acceleration is equal to your actual acceleration.
So, sorry, average acceleration equals
Equals just acceleration. Equals
our constant acceleration. All right.
Because, and then, so you can say, since average acceleration equals the change in velocity over change in time. Then you can substitute that into your displacement formula. Displacement equals v naught t plus 1/2 acceleration times squared. So you can say 1/2
changing velocity over changing time.
Sorry.
So changing velocity is negative.
Basically, we've gone back in our derivation there. Yes? Oh. Yes, we still need that happen. Okay, now what do we want to do next?
And then since you say so 20 meters equals negative or equals 40 meters per second. T plus 1/2 negative 40 meters negative 40 meters per second. T. Yeah.
Okay.
And so you get 20 meters equals 20 meters per second. Because you can just add those together.
T equals 1 second.
And then you can go back and do the same equation again, but just keep acceleration as variable. And then it gives you negative 40 meters.
Okay. Is there another way to get time?
We use the equation v final equals the initial plus at.
Okay.
So then you know v final, the initial, and acceleration, so you solve.
Let me write that again. Can you tell me what you're at?
V final equals v initial plus at.
So he's rearranged this. Okay. And we know this is 0. This was our starting, our 40. And, but we didn't necessarily have that, right?
We found it to be negative 40.
Sorry?
We found it to be negative 40 meters.
So once you solve the problem, you can go back and get
Yeah.
time. Sorry, I was talking about time in terms of solving the problem. What about you guys? Jack, I was discussing with you a way to get time. Do you remember that?
Yeah. You.
I like this one a lot. It's just it clicks in my head. So if we start at 40, end at 0, what was our average? Sorry? Rob? 20. And if we go over here and say, okay, if I'm going on average 20, and now my displacement is 20, I need 1 second to do that. And for me, I mean, everybody's different, but for me, those equations just click. I can do these, but it's painful for me. So, there's usually 3 ways you can solve the problem. You find what's good for you. Does anybody here like graphs? Could we solve, do you think we could solve this with a graph? All right, let's try that. What kind of graph would you use?
You draw like the velocity.
All right, let's do that. So here we're at 0, and in the first part of the problem, we go to, say, 40, right? Boom, and we did it in 5 seconds. Now, in the second problem, we're going to go back to 0. We know it's a shorter time, because we've gone a shorter distance. We're not, let's say we haven't yet figured out it's 1 second yet. So we'll still do that as kind of a mystery. Is there an easy way maybe to figure this out? Talk to each other. What do we know about velocity versus time graph? We were playing with slopes and areas and stuff. See if there's something useful here you can use to solve it.
Okay. So. We're not discussing. This is bad.
Maybe to seed the idea, let's do the first part of the problem again. we said the slope of a velocity curve is what? What's the slope of a velocity curve? Acceleration. So here, this slope here should give us our initial acceleration. And if we say our rise was 40 and our run was 5, yeah, that slope is indeed 8 meters per second squared. So that was pretty slick. What should the area give us? Vincent? What does the area of a velocity graph give you? Displacement. Okay, so let's check that out. We need it to be 100. If we said what is 5 times 40, what would that be? 5 times 4. Add a 0. So the whole rectangle was 200, but of course the half that we're interested was the 100. Okay. Now see if you can use either slope or area or something on the other side to solve this problem.
So. I'm not going to be more by S is.
Did I hear that this is making sense? How about that? Hey, just in time, that's for the next class.
S equals.
Still equal 40 with 8
What do you think? Should I just go and write a big 20 in that mystery triangle? Let's do that. We know that's our displacement during the second part, right? This is going to be 20. Now, if it were again that full rectangle, it would be 40. So 5 times, or I should say, 40 times what time would give us 40? What? All right. So we know now that's 1 second, or a total, we've elapsed to 6. Okay. Now, given that, can we figure out the slope and get the acceleration that way? So our rise was -40, our run was 1, so there we go, we got our -40. So sometimes, we're kind of conditioned to think, well, in graph, that's the last resort, if your calculator's broken or your pencil isn't sharp or something. But here, oh gosh, it seems slick, it seems so much faster than wading through the equations. Plus, it's much easier not to make a mistake doing that. I think here, it's easy to drop a sign or drop a factor 2 or forget to square or something. So, you finish the test, the 60 minutes are enough. Try another method, see if you get the same result. It's a nice way to, check for consistency. Questions? Do you guys like the graphical method? I will. It's like my favorite. It doesn't always work out nicely, but this time it sure did. All right, why don't you guys get to work? I'll pass out your exams. You know the sorts of things to be working on, and then I'll go ahead and post those extra problems, kind of like what we've been solving, that you can work through on your own.
What are you talking about? Where does it go to -1? It doesn't go to -1.
It just goes to 1?
Yeah.
I keep hearing negative 1.
Well, we already finished the quests, so that's cool. Maths. Oh, are you sick? Okay.
Okay, so the problems that I'm alluding to, and again, this is not for credit, it's just for practice, is already listed there under additional resources on Moodle. So the very first thing of the very last section. And like I said, the answers are at the bottom of the page. Alexander. Good. You sit here by yourself, like so basically the question is, did you need to do the same way with your, look like this, like your, wasn't sure. So go ahead and write this line. Hey, in no particular order. Dwayne. Diane. Zoe. Taylor.
Oh no, that's not what I meant. Oh. Oh, come. Oh, that's fair. That's fair.
Tyro. So remember, I need all of them back before you exit.
Does one mean I got something wrong?
Or which is like the 3?
Did you get number
17.089.
Yeah, he gave me a check mark, but he also gave me one, so what
Yeah, I
does that
don't know,
mean?
like, because he said these are 2 points. These are with 2 points. So I'm like, did I get 1 point then? But this is a question. Put a check mark.
I don't know.
Is
Jack, what'd you get for number 5?
something 0?
I know, but I wanted to see if you still got the 1. This is so weird.
Give me a minute. Let me check what my grade is. This was... He counted it for full credit.
Oh, okay.
Full credit? I think this because you could also get half.
The big,
So if you get a 1, it's full credit?
I guess so.
Because 1, you either get 0, 1, half, or 1. Okay, thank you.
The one time he doesn't say to use friction and drag, and I don't put it. The one time he doesn't say to not.
Yeah.
There will be errors as soon as Courtney moves. That is exactly what she is not moving. So, good job.
You put a smile face.
Where did you put all your answers if they're not on the sheet?
I didn't need to do those ones. You don't have to do all of them.
Then why did I do all of them?
Did you understand? Did you understand number 11?
Number 11? Yes.
I mean 10.
Number 10.
No.
I got half a point, but yeah, it was because I like messed something up a little bit.
I don't really understand it. Kind of.
No need to. He put no need to repeat completed problems on mine. Since I did all of the problems, he put no need to repeat completed problems.
Yeah, he did that for me. Wait, you did all of it?
Yes, because I was unsure.
You did.
I don't have self-confidence. Bloop. Wait, why am I getting half a point off for putting extra stuff? That should not be the case if the extra stuff is still technically correct. You can't see. Never mind.
You understand it though?
Yeah. Okay, wait, what's this? Oh, this one I just didn't know. How to math. What'd you get for number 4?
Number 4? Sorry. I didn't do number 4.
Did you do number 4?
I got everything right except so maybe. No, I didn't.
Oh man, okay. 1, 2, 3, 4, 5, 6, 7.
No, that's not what they all say. Like, people say I don't know. Most people say yeah.
Oh, you just do.
It's not what they all say.
Isn't it just 70 minus 45 divided by 600? And number 4? Because doing the second law, the sum of all forces equals mass times acceleration. So if you have them acting on the same time and moving opposite, you would just subtract and divide by 600 to get the acceleration, right?
I think you're right, yeah.
You might want to ask to make sure. I don't want to be telling you the wrong thing.
Do we do corrections on the same sheet?
I have no idea. I think so. Not quite sure. Oh wait, we do corrections? But
We did corrections.
are we doing corrections?
No. You might want to ask him.
Number 6 would we see?
Does that mean there's no lunch or there is lunch today? Is there lunch or is there no lunch today?
I don't.
We still have midday.
Yeah, midday's supposed to be like super long.
Yeah, we have midday, but are they serving lunch?
Let me check.
I I don't think they can't not serve lunch. I think that's illegal.
It's in the lunch time. Because lunch opens at 10:30, the sun's at 10:35. So I'm guessing you're gonna start. You can probably check to see if they have a menu for today though.
I forgot my hot sauce. Yeah. What was his reasoning for not allowing us to have 100s? That doesn't seem like a thing.
You can get them on the web.
The Quest?
Sorry. Same thing.
No, I understand where you describing all the, you were trying to think of
Me too.
Fewer digits.
Oh wow, I don't agree with any of this.
How many digits?
I don't know. A lot. I do a lot. I just put all of the digits that I can.
I mean, that's what I kind of did. But he says fewer digits.
Then probably to the 100th?
I did the 100.
Oh, really?
Like, yeah, and he's like, fewer digits. I'm not sure which one. Yeah, fewer digits. But for this one, he was fine.
I don't know. Ow.
There's no quadratic.
Have you been to help sessions regularly? Wayne, did you have a question?
Is both of them are supposed to be quadratic or?
This one, although it's subtle, see all the points here are above, they're below. In my mind, it's a nice little curve. Now this one's a bit noisier, but I think the straight line is reasonable here.
It doesn't have any quadratics.
Helen. Yeah, polynomial order too, it's the same thing. And then make sure you display the equation.
Did you get this?
I will look at it now. I was just about to log in.
When I do, you click on the
Which lab is that? The
The
detector?
buggy Sparky.
Oh, I got a 90.
Did you get a warning?
No.
Huh.
What does it
It
say?
says this answer is identical to someone else's.
That's weird.
I said the time is in seconds. Like,
That's hilarious.
the only thing I could think of is that we put like, that might have been one of the ones that we put on the shared thing and then like copy and paste it. And it says I may face discipline if it happens again.
Oh my god. Did he?
Did he do that? This answer is identical to this mention if this happens again, he may face discipline.
You should talk to him about that, because even if he didn't put it there, like, he'll see it and be like, oh no.
It says the time.
Wait, did I get 90 out of 0 or 0 out of 90? It's 90 out of 0. If you exit out of the thing on the right, then you could read it.
Wait, what
Better.
units did you get?
For what?
This one is just for velocity.
This is... Here? Why is it so tiny?
Oh. Is it different? Oh.
Oh, but it was tiny.
What?
What the heck? I think it put in... I think it's a bug. I think it got it mixed up with something else. Wait, what does the other incorrect say?
Where?
There, that one. Incorrect. This could be like some kind of glitch. You should look at all these things and see if they all...
No, like some of them make sense.
Oh, okay.
But that one, like, what is this? It's just incorrect, isn't it? Okay. Yeah. That's so helpful.
Your data stops in 3 seconds.
Where?
I don't know.
See, it doesn't stop at 3
Isn't it just centimeters? Wait.
Okay. Maybe by selling it, like selling a data table?
No, that makes no sense. It said, wait, he said human cell.
Oh, it's being like, bro, this can't be right because it cells. It processes cells.
Did I just not convert it? Okay, this one's ridiculous though.
Yeah, he should talk about that one. Maybe if he put it in the wrong place. And
Because I actually do this by myself.
you should talk to him.
And it was like, see if someone else in the class has the same one. The only one that would make sense would be you were doing it.
We don't have it. Let's see. What is this for? Which one?
But it's for the second time.
What's the use the data? Wow, this doesn't do things correctly. Analysis questions. Which analysis questions? Show just be vague as heck.
Wait, what did you get for that?
I got a 90 on this.
No, like, what did you get for that question? Was it a wrong answer?
No, I didn't get anything wrong except.
No, was mine wrong?
Oh. Well, that should be closer together. No, it would be closer together.
I was talking about the warning one.
Oh, the time is in seconds?
Yeah.
Oh, what's the question? Oh, what is the time interval?
Where? I can't see what's beneath it. This is ridiculous. I think I had some other word though.
So since it's a time interval, it's not just, it's in these units, it's
Still, like,
the time interval between each dot. How much time it is between each dot.
still, I'm legit.
I think he just like put it in the wrong place. Oh, you know what? Because that answer like is so vague, it like doesn't really fit the question. He probably like copied it like directly off someone else. No, that would make sense because all your other answers are different. I don't know.
That would not be the one I would copy.
I think it was a glitch.
Because I was legit at home when I was doing this. Because that was why my data was all messed up. I was like, oh, I don't know how to do any of this. This is going to get rid of everything. Where is my lab?
We gonna go talk to him about it?
I'm going to try to find the original document. Because it's not here.
Oh, he didn't do a detector lab yet.
I said the time interval is 1 second.
That's not right. That's why then.
Really?
Yeah, it's 1/60th of a second. You and I talked about this.
I don't know why he thinks I would.
I think maybe it was like just an automatic thing that turned it in, put in. You should like ask. a minute. I think Quest should tell you what the right answer is after the due date. If you got it wrong.
I don't think it's relevant. You never run out of tries. Unless you're like
On Quest?
yeah.
Quest.
Is it gonna take you 7 tries?
Depends, yeah, if it's like one of the fill-in ones.
Dude, at that point you should probably just ask. Because have you ever gotten that far?
There were
Completely missed a question.
Yes.
You don't use average when you use change.
I think. Oh no, I'm not gonna. I'm too lazy. I'm too lazy to find the document with the stuff.
Right, which is maybe 5 or 8, and then you just multiply that by 5.
I mean, there are more precise rules than for now.
How did my shoes come? What's your grade in physics?
93.
Oh man.
Oh, I see.
Okay, you had a question?
Yeah. I was wondering what the learning.
That looked like it had been lifted from somebody else's submission. And that's not a very long piece, but it's very odd that I see that mistake. Did you start with somebody else?
No.
No? Okay. All right, well then it's just coincidental and you can disregard that.
Okay.
But if it weren't, you would need to take that seriously.
Okay.
No, that's needed.
It's such a simple thing that little phrases like that I usually ignore, but when I see a strange answer,
Yeah,
it
I
gets
just
reproduced.
forgot to divide by 60.
I don't know who else did it. Why you? Why isn't it that someone's copying off of you? Because you're great at things.
That seems pretty nice. Okay. Yeah. It's a good way to start. There are rules that you'll learn about in other classes, maybe where they're going to grade you, and then whether you're multiplying or adding matters and stuff. But for right now, you're trimming it to sensible things in my mind, so I'm happy with that. Okay? Yep.
Just a couple minutes to go, I'd like to collect the outstanding exams. All right? Anybody Anybody else holding on to?
Good. That was that.
Yes. Yep. I don't necessarily always carry them with me, but they'll like be in my office and I can get them.
Like if we have a question on one.
Oh yeah, we can always talk. Exams. Pass the crowd.
We didn't have any Amsterdam homework, right? We didn't have any Amsterdam homework, right? No. Cool. What is this paper? Oh, that's where it was. Damn it. Okay.
Okay, but hold on one second. Everybody's assignment over rest, eat, enjoy, and don't forget about this stuff due when you get back on Monday.
I don't think I would have used physics homework this week.
Energy,